What does a scientist look like? Like this? Like this? Or could a STEM professional look like this? Or this? Or this?
Science is a very broad area. So science is often understood as what a child experiences in school, or science is understood as what happens at the bench, in the laboratory. And there have been a lot of studies that that ask people to draw a scientist, sort of think about what a scientist looks like or describe what it means to be a scientist. And often those representations are very stereotypical, very traditional. One of the things that we're really trying to do in the broader field as well as here in the museum is to help people think about what counts as science, right? Science is not just that. It is that, but it's not just that. You know, an environmental educator who's out, doing bird counts, someone thinking about genetic counseling and thinking about what it means to understand how genes work and what that means for heredity. These are all examples of ways in which one can engage in science. One of the things that we know certainly about girls, and we had a recent study released where this idea of what counts as science is really important, because often if the idea of being a scientist is a very narrow view, then it's unappealing and it's not something that is necessarily an area of pursuit or interest. And so girls in particular and youth that aren't interested in that narrow area of science will not follow through.
Lack of a STEM identity is often cited as one of the main reasons that young people do not pursue STEM degrees and careers. A recent study found that most of the participating young people held high career aspirations, but a very small percentage aspired to be scientists. They reported liking science, having positive views of science and scientists, and doing well in school in those subjects. But imagine scientists to be mostly white, middle class, male, and brainy, and thus was not something they could imagine for their own lives. Most of these students and their families also did not understand that science could lead them to a diverse range of promising careers. Research also documents that when children have early positive experiences with science and engineering and are exposed to role models in those fields who have cultural and gender identities like themselves, they are more likely to pursue STEM study and employment.
As a child, I went to school in the Philadelphia district, and it wasn't the best district, so I didn't really have a concentration in science until my parents changed my school to a private school, and I was exposed to all the sciences, and I just fell in love with it. And I felt that if I was exposed to it earlier, I would just have more advances and more opportunity to try things. I just really want to help this generation of kids explore the sciences, because as I'm getting older, I wish that I did these little experiments when I was younger. I just love science myself, that I want everyone to enjoy it and see what I see in science.
These young adults share some of the formative experiences from their childhoods that influenced their decisions about staying involved in science and engineering.
When I guess I was about 5, I got my first tub of Legos. I was building small cars and airplanes, and I'd take the little springs out of pens and steel rubber bands out of my dad's little drawer of some office supplies. Actually, I didn't start thinking about college until I got into 4-H and the FRC, because personally, I hated school. I hated the idea of school, I hated the idea of getting up and going, but I like sitting at home, tinkering. I like taking stuff apart. Like I took apart my mom's bread maker just to get the motor out.
My grandmother had a problem with arthritis. She couldn't open the gas tank on her van. So then I made this thing where it would grip around it would grip around the handle of the gas tank, and then it would almost be like a wheel that you turned rather than just sticking your fingers in and using them to turn it. You had a whole wheel. Actually, I think it was 2 bars. Now that I think of it, but it worked. It did exactly what I wanted it to do. The project that was probably my favorite was the one where we had like these bouncy balls, just regular old bouncy balls. Actually, I think they were made from ping pong balls. And the idea was to get it to bounce the highest. So then what I did was I just coated mine in rubber cement and rubber bands, everything that seemed like it would be bouncy. And then I failed. But it's engineering, you try again.
Having science experiences that are more process-based, having exposure to role models that reflect who they are, being able to work collaboratively and recognize that there's learning that can happen together and for a social good, social purpose. Those are all really important in thinking about what makes science appealing.
Oh, okay. Re-enter the game.